and welcome back. So this is the first video on trigonometry. So in this video we're going to be looking at SOHCAHTOA, and specifically we're going to be using SOHCAHTOA to find missing sides of right angle triangles. So the objective here is to calculate missing sides in right angle triangles using SOHCAHTOA. So a quick note before we get started. SOHCAHTOA applies only to right angle triangles. We need one angle on one side for it to work. So we often label this angle theta, and theta just represents the angle in the right angle triangle. So a quick definition, so the hypotenuse is the longest side of a right angle triangle. So the hypotenuse is that side that's opposite the right angle. The opposite is the side that's opposite the angle in the question. So this is the angle. The side that's opposite the angle is this one. And the adjacent side is the side that's adjacent to the angle. So adjacent means touching, so it's going to be the side that's touching the angle here. So we have the acronym SOHCAHTOA. So SOHCAHTOA basically stands for the three trig identities. So we've got SO, CA and TOA. SO is sine, so sine theta is opposite over hypotenuse. CA is cos, so cos theta is adjacent over hypotenuse. And TOA is tan, and tan theta is opposite over adjacent. So here's an example. So in this question, we need to find the missing side labelled x. So the first thing I'm going to do is I'm going to label my three sides, the opposite, adjacent and hypotenuse. So I've got my opposite side, which is the side that's opposite the angle. So in this case, opposite is x. I've got my hypotenuse, which is the longest side, which is always the side that's opposite the right angle. So this is h. And then the other side is the adjacent side. So that's the side that's touching the angle. So at this point, what I'm going to do is I'm going to cross out the one that's not really involved. So in this case, we can see that the adjacent side isn't really involved. We don't know what the adjacent side is, and we also aren't interested in finding it. So now I'm left with O and H. So at this point, if I write out the acronym SOHCAHTOA, I need to identify the one that involves O and H. So the one that has O and H is clearly SO. So I'm going to write out what SO is. So SO stands for sine theta is opposite over hypotenuse. And then I'm going to substitute in the values I know. So theta is the angle. So in this case, the angle is 30. So I have sine of 30 equals opposite, which is x, over hypotenuse, which is 3. So sine 30 is x over 3. So now to get x by itself, I need to times both sides by 3. So doing so, I end up with x equals 3 times sine 30. And if I type that into my calculator, I should get 1.5. Here's another example. So this time we need to find the missing side labelled x. So step 1 is always to label the sides. So I'm going to label my opposite side. So that's the side that's opposite the angle, which is O. I'm going to label my hypotenuse, which is always the side that's opposite the right angle. So this one's H. And then I have my adjacent side, which is the one that's left and the one that's touching the angle. So then I'm going to cross out the one that's not really involved. So in this question, we want to find A and we know H. So the one that's not really involved in this case is O. So I'm going to cross out the O and I'm left with A and H. So then I'm going to write out SOHCAHTOA. And I'm going to identify the one that involves A and H. So this time, the one that involves A and H is CA. So CA stands for cos theta equals adjacent over hypotenuse. And now I'm going to substitute in the values I have. So theta is the angle, in this case it's 15, so cos of 15. A is the adjacent, which is x, and h is the hypotenuse, which is 5. So cos 15 is x over 5, so now I need to get x by itself. So I'm going to multiply both sides by 5, and I end up with x equals 5 times cos 15. And if I type that into my calculator, I get 4.83. So this example here, we need to find the missing side labelled x again. So I'm going to start off by labelling the sides. So I have my opposite, which is the one that's opposite the angle, so that's x. I have my adjacent, which is the side that's adjacent to the angle, which is here. And I have my hypotenuse, which is the one that's opposite the right angle. So now I'm going to again write out SOHCAHTOA. So this time I'm looking for the one involving O and A, because the H in this case is the one that's not really involved. So I'm going to cross out the H. So O and A is TOA. So this one is tan theta is opposite over adjacent. So if I substitute in the values I know, I have tan of 20, which is the angle, equals opposite, so x over adjacent, which is 12. And now we need to get x by itself, so I need to times both sides by 12. So I end up with x equals 12 tan 20. And then if I type this into my calculator, I get 4.37. Here's another example. So again, I need to label the sides. So I have my opposite side, which is 8. I have my hypotenuse, which is x. And I have my adjacent, which is a. So now I'm going to cross out the one that's not really involved. This time it's a that's not involved. So I'm left with O and H. So if I write out SOHCAHTOA, I'm looking for the one involving O and H. So in this case, it's SO. So if I write out sine theta equals opposite over hypotenuse, I have sine of 10 equals opposite, which is 8, over hypotenuse, which is x. Now this one is a bit different because the x is on the denominator of the fraction. So we need to get x by itself by first timesing by x and then dividing by sine 10. If I times both sides by x, I end up with x sine 10 equals 8. And then if I divide both sides by sine 10, I end up with x equals 8 over sine 10. So in these questions, what ends up happening, if you have x on the denominator, all you really have to do is switch places of sine 10 and x. So in this case, you have 8 over sine 10. Typing that into my calculator, I end up with 46.1. This question here, we need to find the missing side labelled x. So again, I'm going to label the sides. So I have my opposite side here, I have my adjacent side here, and I have my hypotenuse over here. Hypotenuse I can cross out because that one's not really involved. And then I'm going to write SOHCAHTOA. So I need the one involving O and A, so that's TOA. So I have tan theta is opposite over adjacent. Subbing in the values, I have tan of 60 equals opposite, so 10 over adjacent, which is x. And I've just noticed that x is on the denominator again. So if I just switch places of x and sine tan 60, I end up with x equals 10 over tan 60. And that equals 5.77. Okay, so here are some quick fire practice questions on this topic. Pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. Here are the answers, and that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!